Hey guys, so in this scenario we have a student placing a compass 20 centimeters away from a single wire connected to a 9-volt battery, which I've illustrated here, with a 5 ohm resistor placed within the circuit for safety. What is the magnitude of the magnetic field a compass will experience at this 20 centimeter distance? Alright, so the equation that should come to mind when we're looking at the scenario that is going to give us the magnetic field of a wire at a certain distance is going to be the magnetic field of a wire equation. That kind of makes sense. And so I'll write that out for you. That's vacuum permeability times current within the wire times 2 pi r. So the vacuum permeability is a constant, but conceptually we should know that whenever you have a wire that has current running through it, it creates a magnetic field around the wire in a spiraling way. So like so. So that's why the current is important for the wire. So, and then as far as this 2 pi r goes, that's actually the equation for the circumference of a circle. So it makes sense that we're using the radius because since the magnetic field is creating a circle around the wire, if we were to go at any point away from that wire, it is technically the radius of the circular magnetic field that it is creating around the wire. So now that we've got this equation, we got to see, well, what do we have? We have the vacuum permeability, that's the constant, and we have the distance, which is our 20 centimeters, but we don't have the current. So now we got to work backwards, and that's what you'll notice in a lot of these questions is generally you have to work backwards. And so how do we solve for current? Well, we have the resistance and the voltage, and so using that information, we can solve for the current, and we would use our voltage equation, which is resistance times amperes equals voltage. I'm sorry, resistance times current equals voltage. And so that would be 5 ohms times the current that we're solving for times is equal to the 9 volts. And then when we solve for the current, we get that the current is equal to 1.8 amperes. So now we have the 1.8 amperes that we can plug into here. And we have the distance, which we're going to actually use as 0.2 meters. And then here we go, we got the 1.8 amperes. And so when we do the calculations there, we get 1.8 e to the negative 6 Teslas. That should be Teslas. And then the answer is desired in micro Teslas, and so our answer is E.